What happens to x and y values after a reflection? Okay, not gonna lie, I have never once memorized this, so every single time I try and figure this out. So here's what I do. I pick up a pencil, and I imagine that the pencil is the x-axis. And then I pretend to reflect something over it, like my hand. So I say like, okay, here's my hand, I'm gonna reflect it over the x-axis. Boom. Reflect, reflect. Now as I'm doing this, am I moving up and down or am I moving side to side? Yeah, I'm moving up and down. So what am I changing? Am I changing the x values or the y values right now? I'm changing the y values because they're what change when you move up and down. Notice my hand is not moving side to side at all, so I am not changing the x values. So when I reflect over the x-axis, the x coordinates, they stay the same. So I'll drag that over, which means that my y coordinates are going to change from positive to negative, negative to positive. They change to their opposites. Now, doing the complete opposite thing, pencil is the y-axis. I literally do this every time. Okay, so if I have the y coordinates, I take my hand, I reflect it over. Notice now I'm moving from side to side, so I'm changing the x coordinates to their opposites. And my y coordinates are staying the same because I'm not moving the height of my hand at all. Okay, so in thinking about that, now determine the coordinates of the graph following each reflection without drawing them on a graph. So a triangle with vertices blah, 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 blah is reflected over the x-axis. Check up here, reflecting over the x-axis. That means the x coordinates are going to stay the same. So when I look at these are the x coordinates, boom, boom, and boom. Notice in my ending answer, they've stayed the same. But when I think about my y coordinates, they've changed to their opposites. So 3 becomes negative 3. 8 becomes negative 8. 2 becomes negative 2. And that's how you figure it out.